In the modern era, air dominance is a decisive factor in war. Developed nations are racing to develop fifth-generation fighter jet technology to bolster their military strength. One new player capturing global attention is the J-35, China's latest stealth fighter jet. This aircraft is designed not only as a symbol of air power, but also as a serious challenger to Western fighter jet dominance. The development of the J-35 stemmed from China's ambition to rival the air power of the United States and its allies, which had previously dominated with the F-35 Lightning II since the early 2010s. Beijing has recognized that possessing a fifth-generation fighter jet is no longer merely a matter of national pride, but also a strategic imperative to safeguard its sovereignty and military interests in the geopolitically tense Asia-Pacific region. Through the Shenyang Aircraft Corporation, the J-35 project was designed to complement China's fighter jet fleet, which was already strengthened by the J-20. Unlike the J-20, which focused on long-range air superiority, the J-35 is optimized as a multirole fighter jet capable of operating from aircraft carriers and land bases, providing strategic flexibility for the Chinese Navy and Air Force. Furthermore, Beijing is targeting the J-35 as a flagship export product. With a projected lower cost than the F-35, this aircraft is projected to attract the interest of countries seeking to operate fifth-generation fighter jets without relying on Western defense industries. This is what makes the J-35 not just a military project, but also part of China's grand strategy to expand its influence on the global stage. The J-35's design adopts a twin-engine configuration, providing greater thrust and enhancing safety in the event of a single-engine failure during operation. The airframe is constructed using lightweight and strong composite materials, designed to minimize radar cross-section (RCS) and make it difficult to detect by enemy radar. The aircraft's silhouette bears a resemblance to the F-35, but with several adjustments to suit China's operational needs. The cockpit utilizes a bubble canopy design, providing the pilot with a wide all-round view. The cockpit instrument panel incorporates a high-tech touchscreen system, enabling faster and more efficient aircraft operation. Furthermore, the design takes into account the requirements of carrier operations, such as folding wings for maximum space-efficient storage within the ship's hangar. The J-35's internal weapons bay can accommodate a wide range of weapons, including short to medium-range air-to-air missiles, air-to-surface missiles, and GPS-guided precision-guided bombs. This design allows the aircraft to maintain a stealthy profile while carrying weapons, reducing its potential for radar detection and providing an advantage in sorties. The J-35 is equipped with an AESA, Active Electronically Scanned Array, radar capable of detecting and tracking multiple targets simultaneously with high accuracy. This system is a vital component that enables the J-35 to compete with other fifth-generation fighter jets. This radar is combined with an optical infrared sensor to passively detect threats without emitting radar signals that can be detected by the enemy. In addition to the radar, the aircraft features a sensor fusion system that combines data from various internal and external sensors to provide the pilot with a comprehensive picture of the combat situation. With a helmet-mounted display, HMD, the pilot can lock onto a target simply by looking, speeding up reactions in close-range air combat. This technology increases mission effectiveness and allows pilots to make quicker decisions in dynamic situations. In terms of performance, the J-35's twin-engine aircraft was developed to achieve supercruise, flying at supersonic speeds without using afterburners. This provides advantages in fuel economy and reduces the heat signature detectable by heat-seeking missiles. Furthermore, its network-centric warfare capabilities allow the aircraft to connect with drones, warships, and other aircraft in real time, creating a highly effective modern battle network. The development of the J-35 is a strategic project that is costly but considered well worth the expected results. Although exact figures have never been made public, analysts estimate the project is worth several billion US dollars, encompassing research, prototype development, testing, and preparation for mass production. China allocates a portion of its annually increasing defense budget to support the success of this project. One of the J-35's attractions is its lower production cost compared to the F-35. Despite its many similarities in combat capabilities, China leverages lower labor and material costs along with its large mass production capacity to keep the aircraft's unit price down. This allows the government to acquire more aircraft for the same budget, while also opening up opportunities to sell them to other countries at competitive prices. The program also has a significant economic impact domestically, creating jobs in the aerospace industry and stimulating national technological innovation. If exports of the J-35 are successful, the project will not only be a military investment, but also a new source of revenue and diplomatic influence for China on the international stage. The presence of the J-35 is proof that the global military technology race continues to progress rapidly. With its stealthy design, advanced technology, and competitive production costs, the J-35 has the potential to change the landscape of global air power. Although it has not yet been fully tested in real combat, the jet's presence sends a strong signal that air dominance is no longer the monopoly of a handful of countries, but rather an increasingly open and intensely competitive arena in the future.